In this video, we're going to review some of the operations with exponents, and we're mostly going to focus on working with negative exponents, since the rules with positive exponents should all be a review for you in this course. So we'll start with an example of a negative exponent. What does it mean when we have 6 to the negative second power? Well, a negative exponent means that this is a very small number. And when we work with exponents, we don't want to use negative exponents. We want everything to have a positive exponent. So the way that we would rewrite this is we would write this as 1 over 6 to the second power. So by taking, if we think about this as 6 to the negative second over 1, by moving that base with the negative exponent to the denominator, that allows us to make it positive. And so we have 1 over 36 when we evaluate 6 to the second power. In the second example, remember that the exponent only belongs to the x. That negative 3 doesn't also go with the 3. So the 3 gets to stay in the numerator, but I have to move that x to the negative third to the denominator, making it x to the third, because I need to get rid of that negative exponent. So again, by moving it to the denominator, it allows me to take that negative 3 and make it a positive 3. Now in this example, my negative exponent is in the denominator. So what I want to do is I want to take the thing with the negative exponent, which in this case is just the v, not the 6, and I want to move it to the numerator. So I'm going to have v to the fourth on top, and then that 6 stays on the bottom. It just stays where it is because it doesn't have a negative exponent. In the next example, we have a power to a power, which remember means we multiply those two powers together to get negative 4. So this would be y to the negative fourth, but again, I can't have a negative exponent, so I'm going to move it to the denominator, which allows me to make it a positive exponent. Now we have multiple monomials being multiplied together. So the first thing I'm going to do is I'm just going to work through the constants. I'm just going to multiply those. So 3 times 2 is 6 times 8 is 48. And then I'm going to work with the v's next if we're going in alphabetical order. So I just have I have a v to the negative 9th and a v to the 6th. Remember, when we're multiplying, we're just adding those together. So negative 9 plus 6 gives us negative 3. So I have v to the negative third. Then I'm going to go ahead and look at all the y's. So I have a y to the fourth and a y to the fourth, so adding those together, that gives me y to the 8th. And then looking at the x's, I have an x to the negative first and an x to the first. Remember, there's really a 1 there. So altogether, that would give me x to the 0, which is just 1. So my x's are gone. So now I just have to take care of this negative exponent here, so I'm going to move that to the bottom and everything else gets to stay in the numerator. So 48y to the 8th over v to the third. In the next example, remember with quotients we're subtracting, so 2 minus negative 8, remember that minus and negative becomes a plus, and so that gives me x to the 10th. The other thing you could do if you're going to forget that subtracting a negative makes it positive is you could go ahead and move that right away. So I'd still have the x to the second. I know that I have to move that negative exponent up. So I have x to the second times x to the 8th, which gives me x to the 10th. You can do it either way, whichever way makes the most sense for you. Here we have a power to a power that we have to distribute. So remember that that negative third power is going to go to every single thing in that monomial. So I'm going to have 2 to the negative third. Multiplying the powers, I get a to the negative 18th and b to the positive 12, because a negative 4 times a negative 3 is a positive 12. So because that 12 is positive, the b to the 12th can stay in the numerator, but the 2 to the third and the a to the 18th have to go to the denominator. So by moving them to the denominator, that negative 3 went to a positive 3, and that negative 18 went to a positive 18. And then all I need to do now is just take care of that 2 to the 3rd. I need to evaluate that, which is 8. So I have b to the 12th, sorry, I wrote 2, b to the 12th over 8a to the 18th. Now in this next example, I don't want to just start distributing right away like I did in the first one. First of all, I notice that I can simplify this right here. So I can't reduce the 4/3 and it doesn't divide evenly, so I'm just going to leave it as 4/3. And then if I'm subtracting those, I have 3 minus 6, which is negative 3. So I have m to the negative 3 and then all to the negative 2nd. So I can take care of that negative 3 right now and just write this as 4 over 3m to the 3rd, all to the negative 2nd power. Now the way that I can get rid of that negative on the outside is simply to flip the fraction. So I can rewrite this as 3m to the 3rd over 4, all to the 2nd power. And that allows me, by flipping that fraction, it allows me to get rid of the negative here and just make it a positive 2. Now I just need to distribute that 2 to everything inside. So 3 squared is 9. Multiplying the exponents, I get m to the 6th. And then 4 squared is 16. So 9m to the 6th over 16. In this next example, I have negative exponents and positive exponents, but again, I'm just going to start working with the constants. I have 6 divided by 2, which is 3. Then I'm going to look at my m's. I have negative 5 minus 8, which is going to give me m to the negative 13. And then I have negative 9 minus a negative 4. So remember, that's going to become a plus. So that gives me n to the negative 5. So these two things have a negative exponent. They need to move to the denominator. The 3 gets to stay in the numerator. So I have 3 over m to the 13th, m to the 13th, n to the 5th. Right, in this last example, we have many things going on here. We have power to a power, we have a quotient, we also have multiplication. So the first thing I'm going to do is take care of this on the outside. Remember, I can get rid of that negative by simply flipping the fraction. So nothing about the fraction changes, except I just switch the numerator and the denominator, allowing me to make this a 2 instead of a negative 2. And then I still have x to the negative 2nd, z to the 4th over here. Now I can't simplify this quotient here, so I'm just going to go ahead and distribute that 2nd power to everything. So I'm going to have z to the negative 2nd over 9x squared u to the 6th, and I still have times x to the negative 2nd, z to the 4th. Now, if you want to, you can go ahead and move that z to the negative 2nd to the bottom right now. So we'll have 1 over 9x squared u to the 6th, z to the 2nd, times x to the negative 2nd, z to the 4th. And then we're just going to multiply. So I have x to the negative 2nd, z to the 4th in the numerator, because I'm just multiplying that by 1 over 9x squared u to the 6th, z to the 2nd. Now I can simplify this quotient. So with my x's, I have negative 2 minus 2, which will give me x to the negative 4th. So that's going to go to the denominator. So the 9 stays down there, and that'll become x to the 4th. The u to the 6th just stays in the denominator. I have nothing to combine that with. And then if I look at the z's, I have 4 minus 2, which is positive 2, so that can go in the numerator. So I have z squared over 9x to the 4th, u to the 6th.